Hello everyone. Today we are going to see subtractors. In this, we are going to study half subtractor and full subtractor. So let's start. First of all, we'll see what the subtractor are. Subtractor is a combinational circuit which represents the smallest unit for subtraction in digital system. It is mainly used for arithmetic calculation in many device processor. The simplest combinational circuit which performs the arithmetic subtraction of two binary digits is called half subtractor and full subtractor. First of all, we'll see half subtractor. Half subtractor is used to subtract one binary digit from another to give difference output and a borrow output. Here we have a half subtractor. In this, we have a XOR gate, AND gate, and a NOT gate. This XOR gate will gives the difference output, and the AND gate will gives the borrow output. Now let us see the truth table for the half adder. Here we have a simplified logic equation for half adder. The difference output is given by A negation B plus AB negation, which will be given by the XOR gate, and the borrow output is given by A negation B. Here, the difference, that is the D output, is an XOR gate and the borrow is BO. It is a AND gate with complemented input A. The expression for borrow in case of half subtractor is same with carry of the half adder. However, the case of borrow output, the minuend is complemented and then ANDing is done. A half subtractor is a combinational logic circuit that subtracts one bit from the another. This circuit has two inputs, A and B, the minuend and the subtractant bit. The two outputs, that is the difference and the borrow bit. A practical use of this half subtractor is for full subtractor in a digital system. Here, this output difference can be obtained by simply putting the values of A negation B plus A B negation. Since we have 0 in 0 0 input A and B, negation of A will be 1 and negation of B will be 1. So when we put these values over here, that is negation of A is 1 and B is 0. So this term will be 0 for the first step, plus A is 0 and negation of B is 1. So again this step will be 0 and the sum of the two will be 0. So likewise, simply putting the values for A and B and the values of A negation and B negation for difference as well as borrow, the truth table can be verified. So let us proceed. Now we switch to the full subtractor. The full subtractor makes subtraction of two bits. One is minuend and other is subtractant. In full subtractor, one is lent by the previous adjacent lower minimum bit. Hence, there are three bits measured at the input of the full subtractor. Here you can observe a logic gate diagram for full subtractor. It is nothing but the combination of two half subtractor. This is the one half subtractor and this is the another one. And the two half subtractor were combined and joined with a OR gate which gives the borrow output. And the difference output is given by the second XOR gate. Now let us see the simplified equation for truth table of full subtractor. Here we have A negation, B negation, B input plus A negation, B input negation plus AB negation, B input negation plus B input. This will give the difference and the borrow will be given by A negation, B input plus B input plus A negation B, where we have this A, B and B input. These three are the inputs and the output is difference and B output. Okay, so what we can say, there are two outputs that are difference and B output, that is borrow. The borrow output indicates that the minuend bit requires borrow 1 from the ensuing minuend bit. If we compare difference output and borrow output with full adder, it can be seen that the difference output D is same as that for the sum output. In the earlier video, we had learned adders in which we had studied full adder. So here we are simply comparing this difference D column with the full adder sum column, and it was observed that they are same. Further, the borrow output BO is like carry output. In the case of half subtractor, an input is accompanied, similar things are carried out in full subtractor. A full subtractor is a combinational circuit that performs the subtraction between two bits. Okay, this is simply the subtraction between two bits. And considering the borrow input for a lower noteworthy stage, a full subtractor can also be implemented with two half subtractor and one OR gate, as we have seen in the logic diagram. The difference output from the second half subtractor is the exclusive OR of borrow input. Okay, and the output of the first half subtractor, which is same as variance output of full subtractor. So this circuit have three inputs, A, B and B in, and signifies the minuend subtractant. This is minuend, this is subtractant and this is previous borrow. And the two outputs, difference and borrow output. Okay, with this, we'll switch to the applications of these subtractors. This HalfSubtractor is used to reduce the force of audio or radio signals. It is used in amplifiers to reduce the sound distortion. It is also used to increase and decrease operators and also calculates the addresses. It is used to subtract the least significant column numbers for the subtraction of multi-digit number. It can be used for the LSB. These subtractors can be employed for ALU in computers. They are mostly used for performing arithmetical functions like subtraction in electronic calculator as well as digital devices. They are used in processors to compute tables, addresses, etc. Full subtractor is also useful for DSP and networking based system. These are mainly used to perform arithmetical functions such as subtraction within digital devices and calculators. These subtractors are also appropriate for various microcontrollers or timers. With this, I stop here. Thank you.